What's up, sports fans? Today we're talking slope-intercept form. I'm here on page 7. We're going to do page 7, page 8, page 23. Feel free to pause, rewind, do whatever you need to do to make sure this makes sense. I'm going to move through fairly quickly. So slope-intercept form, I think you've seen it before. We know that linear equations are frequently written in this form, slope-intercept. We know this as y equals mx plus b form a lot of times. M represents the slope, I have that in green. B represents the y-intercept here in pink. Notice how the slope has it's not the x. So when we're looking at something in slope-intercept form, the slope is the number. The slope is the m, the slope is not the x. It's the number that's attached to the x. So whenever you're asked for slope of something, it never has an x in it. Notice how all these slope is presented to us or given to us. None of these have x's in them. Slope is only going to be a number. It's a rise over run number. Okay, let's get into this. What if we're given the slope? What if we're given the y-intercept? Can we create an equation in this form just from this given information? We'll do it from pictures here in a little bit. So here we go. I'm looking at number 1. The slope is 2. The y-intercept is -1. So the slope, I'm going to color code this again. That's the green stuff. In fact, I'm going to do this all the way down just to make my life a little easier. I like to color code things for myself. The y-intercept, that's the stuff here in pink. Now it's a situation where we're just going to kind of plug and play. We're going to follow the model that's here before us. All these are going to have a y equals, there's going to be an x, and then a plus b. Well, what's before the x? It's the m. It's m times x. In this case, our m is 2. And we're adding a value of b. In this case, it's kind of funny. So we're adding a -1. That's the same thing as subtracting 1. So this is our y equals mx plus b. M is 2 because the slope is 2. B is -1 because the y-intercept is -1. And this equation is complete. Let's move on to the next one. Playing the same game here. Y equals. This time our slope is a fraction and it's a negative. Okay, cool. We're doing the same thing. -3/5. And that's times x. Again, the slope is just the number, just the green stuff. X is just x. This is the input. Whenever x changes, the y value changes by this much, by -3/5 in this case, or it goes up by 2 in this case. The y-intercept of 4, so we're adding this time because this 4 is positive, and there we have it. A couple more just for funsies. I'm going to do number 4 and number 5. I'm going to leave 3 and 6 for you to do on your own. Here we go. Y equals. Well, this one's a little interesting. It's a slope of -1. You totally could write -1 times x, and then the y-intercept is 7, so we're adding a value of 7. That's not wrong, but generally speaking, when we multiply something by 1, we don't write the 1 there, so you could totally write y equals -x plus 7. These two equations are telling the same story. They mean the same thing. They're both equally as true. I don't have a preference for which one you use. Generally speaking, mathematicians will use something like this. Generally speaking, folks who are newer to the game will use something like this. That's okay. They're both equally as accurate. Number 5, y equals, again, the green stuff, 1/4 times our x. So this is y equals mx. Well, now we're going to add our b, but our b value in this case is 0. Well, we totally, again, we could write +0, and that's not wrong. But if we wanted to write this a little more efficiently, we don't have to write +0. So y equals 1/4 x. End of thought. Like that can be all the way done. Just like when you add 0 to anything, you don't have to note that you're adding 0 because it doesn't actually change the value. Okay, let's play the same game. This time we're doing it from pictures. We're doing it from the graph. We're going to identify our slope. We're going to identify our y-intercept. Remember that slope is rise over run. You could also do the y2 minus y1 over x2 minus x1. That's from the previous lesson. 2 points here are identified. I'm going to look at how much this rises, how much it runs. This looks like it goes up 1, 2, 3 units, and it runs 1. So my m is 3/1. Which of course can be simplified to just 3. Now let's look at our b. Remember that b is the y-intercept. This is where the line crosses the y-axis. The y-axis is always this line that goes straight up and down through the origin. I'm going to highlight this one just to make it abundantly clear where it is. I'll do it the same over here. So we're just looking for where does this line cross the y-axis? Well, in this particular case, it's right here. So from the origin, we go down 1, 2, 3, 4 units. So our b is at -4. Our y-intercept is at -4. Now we have the same information we did above, so we just do what we did above. Y equals mx plus b, but again, in this case, the b is negative, just like it was for number 1 above. So we're going to write -4. We're adding a -4, which is the same thing as subtracting 4. Number 8, let's identify our slope again. I always do these things from left to right, so I'm going from this point here I'm pointing to the other one. Our rise is a -1, 2, 3, 4, 5, 6. So it's going to be a -6 in our numerator. And then I'm running 1, 2, 3, 4 units. -6/4 can be reduced. I'm noticing that 2 goes into both these values, so that's going to be the same thing as -3/2. -6 divided by 2 is -3. 4 divided by 2 is 2, so this is our slope. Our b value, again, looking at the picture, the graph crosses right here. So from the origin, we go up 1, 2, 3, 4, 5, 6, 7 units. Our b value is 7. Plug in the pieces to y equals mx plus b now. Y equals mx plus b. There you have it. Let's look at a couple more of these just to make sure that things are landing for you. If you want to skip any of this to get to the word problems, feel free. You're not going to hurt my feelings. So here we're going to move things a little bit quicker. Again, we're playing the same game though, finding the slope to get from one point to another. There's nothing particularly special about these 2 points. We could pick any point that crosses through one of these corners. I'm going to go with the ones that are marked here, but you could pick any of these other ones and you would get the same thing. So to get from the left point to the right point, we have to rise 1, 2, 3, 4, 5 units, and we have to run 1, 2, 3, 4, 5 units. Okay, strange. So our m is rise over run. Well, it's 5/5. That's the same thing as 1. So our m value is 1. Y equals 1 x, and then we'll look at the y-intercept now. It's down here. So from the origin, it goes down 1, 2, 3, 4, 5, 6. Great, -6. Again, you could write this as y equals x minus 6. You don't need that 1, but it's not wrong. Moving on. This one here, we're looking for the slope first. It rises 1, 2, 3, 4 units, and it runs 3. 1, 2, 3. So our slope is 4/3. Our y-intercept, it's right here at the origin, so our b value is 0. I didn't note that the b is -6 up here. Okay, so it goes through that. That means we don't really even need to write this down. This is another +0 situation. So the equation here can simply be y equals 4/3 x. And again, you can put +0 or not. I'm not going to because it's not essential information. I'm going to do one more on this page before I bounce over to page 23. Number 14 is next. I'm noticing this is a nice negative slope. Let's see what the slope actually is. From this point here I'm pointing to this other point here down here, we rise a -1, 2, 3, 4, 5 units, and we run 1, 2, 3, 4, 5, 6. Interesting. So the m here is -5/6. The b value, the y-intercept from the origin, we go up 1 unit. So that means the b value is 1. Plug this business in. Y equals -5/6 x, and then a b value of 1. So we add 1. Again, feel free to pause, rewind, do whatever you need to do. Just make sure that things are landing for you. I'm going to bounce over to page 23 now, and we're going to do just a few of these. We're playing the exact same game, but now we're presented with more real-life sort of applications to these. There's words, obviously. I know words kind of freak us out a little bit. So stay tuned because we're playing the exact same game. For each of these, we're going to read the situation. We're going to identify our m, identify our b, create a thing in y equals mx plus b form, and then we're actually going to use that equation to answer the question. So let's wrap our mind around this. Evan is going to the county fair this weekend. The admission to the fair is $5. The cost per ride is 50 cents. His parents gave him $20. Write and solve a linear equation to find out how many rides he can go on. Okay, interesting. So I'm noticing that the thing that changes here is how much money he's going to spend per ride. So if he goes on one ride, he spends 50 cents. 2 rides, he spends $1. 10 rides, he spends $5. So that's the thing that's changing a lot. That's going to be our rate of change. I'm noticing that the admission to the fair is $5. He's only got to pay that once. So we're going to refer to that as our y-intercept. Because when he's ridden 0 rides, he still has to spend this $5. So our b value is going to be 5, whereas our slope here is 50 cents. I'm going to call that 0.5. Okay, so we'll put it into y equals mx plus b form. Y equals m x plus b. So this is the equation we're going to work with. But remember, we're not done yet because this question asks how many rides can our friend Evan go on if he has $20. Well, in this case, if we plug in, this number x in this case represents the number of rides being ridden. And this is what we're trying to solve for. The y represents the total amount of money spent. Well, it looks like Evan's parents gave him $20, and it looks like he's trying to spend the whole entire $20. So we're going to set up this equation as 20 equals 0.5x plus 5. So this is, we're spending $20. Each ride costs 50 cents, and admission to the fair is $5. Let's go ahead and solve this thing to figure out how many rides our friend Evan can ride. I'm going to subtract 5 from both sides. Remember, my goal here is to get the x all by itself. It's going to take me 2 steps. 20 minus 5 is 15, and then we still have half of an x. Well, there's a couple different ways we can approach this. We can divide this by 0.5, which is kind of the way that I imagine most of us will take it. We could also multiply it by 2, because remember, the whole goal is to get 1x over here. Right now, we have half of an x, or 0.5 of an x. I'm going to do the division step, but for the nerds in the room, keep in mind there's different ways to approach these types of things. So we'll divide by 0.5, divide by 0.5, and you are more than welcome to use a calculator here. So I'm just typing in 15 divided by 0.5. That's what's going on right here. When I click enter, my calculator friend tells me 30. So then I learn, I'm going to bring it right up here, 30 equals x. Of course, I'm going to flip that around. X equals 30. Well, the question didn't say, what does x equal? The question says, how many rides can he go on? So Evan, our friend, can go on 30 rides. We've reached the end of that one. I'm going to do one more of these. We'll wrap up this video. Thanks for your time. Thanks for your attention. I think this is going to be helpful. Let's look at number 3. Our friend Alex, he bought a new truck for $42,935. Okay, cool. Good for Alex. According to the dealer, the truck is going to depreciate approximately $4,200 a year. Write and solve a linear equation to find out how many years until the truck is only worth $5,135. Oof, okay. So again, I'm looking for the thing that changes. It looks like it's changing $4,200 a year. That's going to be our slope. And it's depreciating. It's going down in value. Like most vehicles, when you buy them new for a big old price tag, it's going to lose value every year. So in this case, it's losing, so negative, $4,200 a year, or $4,200 a year. Our b value is going to be our initial value, the y-intercept. So after 0 years, how much did the truck cost? Well, it was $42,935. So putting this in y equals mx plus b form, y equals negative 4,200 x, and then we're adding our b value, plus 42,935. What this equation tells us is the total value of the car, that's our y, that's our output, after X number of years. So after 0 years, right when you bought the car, right off the lot, you plug in 0 for this, and then 0 times green stuff is just 0. The car is worth $42,935, exactly what he paid for it. Cool. After 1 year, we'd plug in a 1 right here. Now this value, this term is negative $4,200. So it's whatever pink stuff is minus $4,200. And that would be your total amount of money, total amount of whatever the car is worth. After 2 years, you know, the numbers just keep changing and whatnot. Now, of course, there's a limit to this in real life situation because say we plugged in the number 100 here, then the car would be worth negative money, and that doesn't really make sense. And of course, the truck isn't going to be around in 100 years more than likely. So there is a limit to how powerful this linear equation will work in a situation like this. But in general, it works just fine. So this is the equation y equals mx plus b form. The question asks us, write and solve a linear equation to find out how many years until the truck is worth $5,135. Okay, so that's the total value, $5,135. That's our y, and then we're using the rest of our mx plus b. 4,200x plus 4,2,935. Okay. 2 steps. We're going to subtract this mess from both sides. We'll divide both sides by 4,200, and we'll cross our fingers real hard that we get a nice whole number here. 42935 minus 42935. This step here is going to look a little weird, feel a little weird, but we can work with it. So again, I'm going to ask my calculator. 5135 minus 42935. And I get a big old negative number that feels uncomfortable, but it's going to work out. So 37,800 equals negative 4,200x. So the deal here is we have to divide both sides by negative 4,200. This side's already negative. Negative divided by negative will yield us a positive. So this thing is going to work out. So again, on my calculator, divided by negative 4,200, and then we end up with a nice clean number of 9. So 9 equals x. Again, this question didn't ask us what x equals. It asked us how many years until the truck is worth this much money, and we just found that it was 9. So we can say 9 years. If you wanted to be exact, you could say 9 years until the truck is worth $5,135. Okay, you have a few other examples to work on. You can check the Everything doc for solutions to those, even though they're not in this video. Hey, thanks for your time. I think it's time well spent.